So today we are going to learn about deploy and configuring core network services. In this session, we are going to learn we can deploy a core network, enterprise network, using our Windows Server 2012. So for today's class is something this. Okay, in this class, deploy dynamic host configuration protocol, which is known as DHCP services, and we also learn about the deploy and configuring of DNS services. Okay, so let's begin with the first objective. There is configuring IPv4 and IPv6 addressing. Configure IPv4 and addressing. Basically, server should be familiar with the basic principle of IPv4 and IPv6 address spaces. So, if we want to configure any server network in addressing, so we have two options left. One is IPv4 addressing, another is IPv6 addressing. So as you know, to work with them, IPv4 and IPv6, we should have a basic knowledge about how to assign IPv4 address. We are going to learn it in detail. So what is IPv4 addressing actually? The IPv4 address space, as you know, probably consists of 32-bit addresses, noted as 4 8-bit decimal value from 0 to 255 is the range, separated by periods as in the example of 192, 168, 43 and 100. This is known as dotted decimal notation. So this is basically, that means 192 dot. This dot is known as dotted decimal notation. And the individual 8-bit decimal values are okay. So each address consists of network bits which identify a network and host bits which identify a particular device on that network. To differentiate the network bits from host bits, each address must have a subnet mask. So this is the basic identification rule of IPv4 addressing. So whenever we are IPv4, we should keep in mind that this address has 32-bit address, meaning 32-bit address, and each octet has 8-bit on it. So we can get up to 4 octets. For example, we have the address of 192.168.43.100. In this IP address, the dot is known as dotted decimal notation, and each an individual octet having 8 decimal values, which is called octets or bytes. Okay? Each address consists of network bits which identify the network path and host bits which identify the particular device on the network. To differentiate the network bits and host bits, each address must have a subnet mask available. So, subnet mask is the only option by which we can identify who are the IPv4 network path and who are the IPv4 host path. Host path can be distributed over LAN, but network path cannot be changed. Now let's learn about what is subnet mask. A subnet mask is another 32-bit value consists of binary 1 bit and 0 bit. So guys, as you know, in binary, in binary, we can have only two number of bits. One is on bit, one is off bit. Off bit is denoted as 0 and on bit is denoted as 1. So in total IPv4, we are getting 32-bit address, right? So in this 32 bits, there may be 32 on bits or maybe 32 off bits or variables. The bits corresponding to the 1s in the mask and network bits as well, and the bits corresponding to the zeros are the host bits. Now, if you use 192.168.43.100 address mentioned either of 255, 255, 255 and 0, which is the binary form of 111118, 24 number of 1, and rest 8 bit will be on 0. The first 3 octets, 192.168.43, identified as a network part, and the last octet, 100, is identified as a host. In a single octet, in a single host part, we can get up to 256 number of IP address, 0 to 255. That means total 256. Out of this 256, 2 IP will be deducted. The first IP as network address and the last IP address is used for broadcast address. So if we minus the 2 number of IPs from 256, then we'll get 254 active IPs which can be distributed over LAN. So now learn about classful and classless addressing. What is IPv4 classful addressing? Because the subnet mask associates with IP address and can vary, so can the number of bits used to identify the protocol. IP standard defines 3 classes of IP addressing, which provide support for network to different sizes. The first bit value by class A supports 0, class B supports 10, and class C supports 110. The first byte value decimal, if we found, then class A having an address of 0 to 127, class B having a start address of 128 to 191, and class C will start from 192 to 223. The number of network identifier bits available in class A is 8, in class B it is 16, and class C it is 24. The number of host identifier bits available in class A is 24, class B having 16 number of host class, and class C having only 8 number of host class. Number of possible networks. In class A, we can have 126 16,384, and in class C we can get 2,97,152 number of possible network. So network size difference is in terms of hosts. That means how much address we can utilize in class A. In class A, we can get up to 1,67,77,201 number of end user and IPs. That means host addresses. In class B, we can get 65,534 number, and in class 254 usable IPs in per class. So this is which is known as classful addressing. Okay, classful means there is no subnet available. We can only use the default classes available with class A, B, or C. That is known as classful addressing. Additional note about the IPv4 is, in addition to class A, B, and C, the IP standard also defines two additional addresses, class D and class E. Class D addresses begin with the bit value of 1110, and class E addresses begin with the value of 11110. The Internet Assigned Number Authority, which is known as IANA, has allocated class D address for use identifier. A multicast address identify a group of computers on a network, all of which process a similar trait. Multicast address enable TCP/IP applications to send traffic to computers that perform specific functions such as all router network, even if they are located in a different subnet. Class E addressing are understand. So this is the actual thing in class. We cannot use class B and class E. This is the fact, guys. Hello? Guys, are you able to hear my voice now? Please respond. Ranjit. Sumit, Shantanu. Okay, just hold on. Okay, great. All are able to hear my voice. Okay.
Hello. Hello.
So let's start with the next slide. Now we are learn about the domain routing. At the time IP was developed. So classless is a different thing. So to understand that, we have to know the history. At the IP was developed. That means when first TCP/IP protocol developed, no one at 32-bit address space would ever be expanded. That means it will be end. So at the time of the development, they think that 32-bit is enough for all, enough for entire world. In the 90s, 80s, there were no network, 5,536 computers. Never mind 16 million. And no one worried about the wastefulness or assigning IP address based on these classes. Because of that, wastefulness or classful addressing was gradually obsoleted by a series of subnetting methods. So it is basically a subnetting method. That means a network can be divided into smaller networks, 2, 3, 4 number of small networks, including the variable length subnet mask, which is known as VLSM, and community class domain routing, that is classless internet, which is known as CIDR value, CIDR is a subnetting method. So CIDR is basically, what is this? It is basically a subnetting method that enable administrator to place the division between the network bit and the host bit anywhere in the address, not just between. This make it possible to create network of almost any sizes. So this is the actual benefit why the CIDR or VLSM is introduced. Because basically when they are using class full routing, class full interdomain routing, at that time they have to use the entire network, whereas they don't have that much client on their network. So to segregate that on a smaller network, we demand new subnetting method, which is also known as classless interdomain routing. And for that, CIDR value has been introduced. In this CIDR value, it is basically a subnetting method. Okay? And in this, using this subnet, we can create multiple subnetworks in a network according to our needs, according to our size demand. I got a question, I think. Okay, no. Now the CIDR also introduced a new version of network addressing. A standard dotted decimal address representing the network is followed by a forward slash and naturally specifying the size of the network identifying prefix. For example, for class C, we can use 192.168.43.0/24. Here, /24 represents a single class C address that use 24-bit network identifier. Leaving the 8-bit for up to 254 host identifier, each of these hosts would receive on address from 192.168.43.1 to 192.168.43.254 using the subnet mask of 255.255.255.0. CIDR also introduced a new nation of network address is standard dotted decimal address representing the network is followed by a forward slash and naturally specifying the size of the network. So this is the actual thing, guys. Why we are trying to understand CIDR because from now onwards we are always talking about CIDR values. Because suppose you think about a class A, class B or class C addresses, the default network value, whatever the network value available in the network can be represented as a CIDR. So this is the use of CIDR, and by this CIDR we can start subnetting our network. We can give you a brief idea. If you can go with something to, let me show you on online. Here you can get a great idea about go to Google and search for the subnet calculator. Once you get the subnet calculator, open the subnet calculator so that you can have an idea. So here we can have network classes, class A, class B and class C, right? In this class, if we use the default address 192.168.0.1 with the subnet mask of 255.245.255.0, the mask bit will be 24. So this is the CIDR value, guys, 24. So in this class, we can see the first octet range will be 192 to 223. and we are getting IP address from 0 to 255, right? And the host address will be used from 1 to 254. If we change a CIDR value of 25, then what will happen? Then you can see the subnet mask will change automatically. It is 128 now. And we can get one subnet bit, right? And we can get two subnets, sub-networks. Now, if we enable single one bit, we can get two different networks. One network comes from 1 to 226, and another is 227 to rest of the addresses. This is the actual example of subnet. Same thing, if you can go to the 26, it will change again. Subnet mask will automatically change, and now in this network, in this CIDR, you can get up to 4 subnetworks. If you can click on one, what will happen? It will again go back to the 24 number of network bits. So according to your need, you can select up to 64 sub-networks, okay? But in Class C, it is not possible. Class C, 64 bits, 64 sub-networks is only possible when we use 252 as a subnet mask. And you can get only 2 addresses in this network, 1 or 2. Okay? Guys, so this is the live example how you can do the subnets in IPv4 using the CIDR value. So guys, here I am giving you example of CIDR values. Here we use /26 network. As you can see, simple CIDR 192.168.43.0/26 network. If the administrator needs more than 4 subnetworks, changing the address 192.168.43.02/28 address to more bits on the network address for a number of 16 subnets, each of which can support up to 14 hosts. The subnet mask for these networks would therefore be 255, 255, 255, 240. Some examples are right, as you can see, network address of 192.168.43.0 is adding a starting address of 192.168.43.1 to the ending address of 192.168.43.62, and the subnet mask will be 192. That means 255, 255, 255, 192. In the same subnet, we can get up to 4 subnetworks. Each subnetwork having total 64 number of IP addresses, where we can use only 62. Rest 2 will be used, one will be used as a network address, one will be used as a network broadcast address. So in this 4 networks, the 4 network slide has been shown in the right hand side. Till that time, if you have any doubts, please raise your hand. If you have any doubts to understand what is CIDR, please raise your hand or put your question in the wall. Anyone on the team? PMG, do you have any problem to understand what is IPv4 classless and classful routing? And do you have understand the CIDR and its use to creating subnetworks? Sumit, do you have any issues to understand this? Kantanu, please let me know if you have any understanding related challenges.
Dada.
Yeah.
Hello.
Please tell me.
দাদা আমরা যে এখানে সাবনেট মাস্কটা করছি এই যে যেমন 192.168.43.0/26 তো এটা 192.168 আমরা ক্লাস ক্লাস এ আইপিভি যাচ্ছে, কিন্তু এখানে /26/12 এরকম যে ব্যাপারটা থাকে, এটা তো হোস্টটা ক্যালকুলেশন করলাম সাবনেট মার্কস থেকে, বাট 26/12 এই জিনিসটা বুঝতে পারছি না।
This is called CIPR value, classless inter-domain routing.
Classless, yes.
CIPR basically used to identify the number of active network bits on a IP address. And CIPR also reflects as a subnet mask. It is a representation of subnet mask only. If we have 255 in a single octet, that means the 8 number of bits are on. That's why if you can add one by one, 8 number of bits, you can get 255 is the value.
255.
Okay?
Okay.
And, hello?
Hello?
Yeah. So CIDR basically identify you what is your subnet mask, and based on the subnet mask, the CIDR value will be calculated.
Yes. Okay.
Any more doubts?
No.
Any more doubts? Let's continue then. Okay, I got a message from Chiranjeev. He might have some problem. Yes, sir, I am adding the old city password. Great. You guys understand that? So let's move to the next slide. Public and private IPv4 addressing. You should know about what is public class and what is private class, because in IPv4 as well, we cannot even use the public class IP address, because public class is sellable IP address, which can be sold by the ISP at your area. Okay? And we can only use the free or private addressing. So let's learn about private and public IPv4 addressing. For a computer to be associated from the internet must have an IP address that is both registered. All of the web servers, internet, have registered addresses, as do all of the other types of internet servers as well. So, what I can understand, if you want to use the internet, then you must have a identity before you start accessing the internet. So, what is identity? Identity is basically a unique IP address which is universally independent or unique, and there is another copy of that IP address is available with anyone in the world. So this is basically what makes the IP address as a unique. So that is the ultimate source for all registered addresses. So if we want to purchase any IP address, the authority will be INA. But INA do not sell any IP to any end customer. So how an end customer can get a IP address? So for that, INA will sell their IP address range to the ISPs, and the ISPs then sell it to the customer. So this is the process how you can get a public IP address. That is basically managed by Internet Corporation of Assigned Names and Numbers, which is known as ICANN. This organization logs of addresses to the internet, which is known as RIR. So, which allocate the smaller blocks in terms of ISP. So, ISP. Yes. Hello. An organization that to host a server on the internet typically obtain a registered address. So if I am a client and I want to publish my web server over the internet, in that case I have to purchase or I have to buy an IP address from the ISP end. The 3 blocks of addresses allocated for private use are for private IP addressing. The first is 10.0.0.0/8. It is for class A, and 172.16.0.0 will be used as class, and 192.168.0.0/16 will be used as class C. The network use the addresses from these blocks for their workstations. It doesn't matter if other organizations address also, but the workstations are never directly connected on the same network. So if we use any private address in our local network, that means LAN network, that same IP address pool can be used in different organizations in their, that is no clash. But the only challenge is we are never going to communicate with each other. So this is the fact actually. So let's learn about the IPv4 subnetting now. In most cases, enterprises are use addresses in one of the private IP address range to create the subnet they need. If you are building a new enterprise network switch, you can choose any of subnetting along the octet boundaries. For example, you can take the 10.0.0.0/8 private IP address IP range and use the octet as a subnet ID. So this enables you to create up to 256 subnets with a many of 55,536 number of hosts each one of the networks. So the subnet mask of all of the address subnet will be 255.0.0, and will proceed as follows: 10.0.0.0/16, 10.1.0.0/16, 10.2.0.0/16. So this is the benefit we can get using IPv4 subnetting. Now learn about what is supernetting. In addition to simplifying the network notation, PIDR also makes a technique which is called IP address aggregation or supernetting possible. Supernetting, that is something different. It is not subnetting, it is supernetting, which can help to reduce the size of internal routing tables. A supernet table, a combination of continuous networks that all contain a common PIDR traffic. When a organization progress multiple continuous, that can be explained as a subnet or supernet. It becomes possible to list this network to an routing table using only one entry instead of many. For example, suppose you are using 172.16.43.0/24. On the different side of your LAN, you can use 172.16.44.0/24. It will help you to use a single route or route to this particular two different networks. They are different networks. There is no doubt that there is two networks which is defined. One is 43.0, one is 44.0. But the difference is the CITR value will be same. So this is why it is known as supernetting. And the benefit of using supernetting is if you use a supernetting on your local network, then the routing for the each and every sub-networks will be limited. Because if you can use 172.16.0.0/24 as a routing source host, then both the network can be routed from the single static rule. So this is actually the benefit of supernetting. Any doubts? Please let me know. Guys, have you understand what is supernetting and what is subnetting? In subnetting, you can get 172.16.43.0/25. And the subnet mask will be 255.128. So the network class will be different because the subnet mask is different. But in supernetting, the subnet mask will be same, but the network will be different. Do you have any doubts? If you have any doubts, please let me know so that I can answer your queries, and either or I can continue to the next slide. Okay. Now we are learning about defining IPv4 addresses. A server or network administrator must be familiar with the method for deploying IP address to the computer on a network. To IPv4 address, there are three basic alternatives. One is manual configuration. Manual configuration means you have to go to the server, network device, or any endpoint, that means end customer machine, and manually enter the IP address on the IPv4 string. This is one option we have. Second option is Dynamic Host Control Protocol, which is known as DHCP. So DHCP is the most efficient protocol by which we can deploy IP addresses to our network. And the third is Automatic IP, which is known as APIPA. You all heard about the term. Yes, this is called APIPA. So three type of IP configuration is available in the market. One is manual configuration, second is DHCP, and the third one is automatic, which is known as APIPA. An address started with 169.254.0.0/16 is known as. So anywhere, if you can see a IP address starts with 169.254.0.0, it's basically a APIPA address. APIPA. When APIPA appears, when the manual system will not be available, and then it will find for DHCP server. But if the DHCP is also not available, then it will automatically take up the APIPA IP address in their network adapter. APIPA is a private IP address and non-routable. It cannot be routed. So we have completed, guys. We have completed with IPv4. Now we have IPv6 addressing. So what is IPv6 addressing? As most administrator knows, IPv6 is designed to increase the size of IP address spaces, thus providing the address for many more devices. The 128-bit address IPv6 allows for 2 into 128 possibly address, and an anonymous number that works out of over 54 million address each square meters of the Earth surface. So if we can plan it out, each square feet of Earth surface may contain of 54 million addresses. So this is the capacity of IPv6 addresses. In addition to providing more addresses, IPv6 will also reduce the size of routing tables. In the routers scattered around the internet, this is because the size of the is more than the two level of subnetting currently possible with IPv4. Introduction with IPv6 is IPv6 address are different from IPv4 address in many ways. Other than instead of the 4-8-bit decimal number separated by the pairs of IPv4 users, IPv6 address use a nation called comma hexadecimal format, which consists of 8 or 16 hexadecimal numbers separately by a colon. It is as follows. As you can see on the example, it is XX colon XX colon XX colon XX colon XX. So this is the actually syntax in terms of IPv4. In IPv4, your specification will be differentiation with the dot value, 192.168, right? But in IPv6, you have to use colon instead of using dots. Each X requires have 8 bits or 1 byte. Which is hexadecimal notation is represented by 2 characters as in the following example. If you want to use a full-fledged IPv6, it would look like something like that. 21 CD colon 53 colon 0000 colon 0000 colon E8BB and more. So this is the actual example of IPv6 address. Contracting IPv6 addresses. When an IP address has 2 or more contradictory 8 bits of zeros, you can replace them with a double colon as follows. So on the downstairs you can see we have 2 octets with complete 0. So instead writing that root 0 on the bits, you can use double colon to denote as a 2 different 0 bits. Experiencing IPv6 network address. There are no subnet masks. There is no subnet mask available in IPv6. So now the question arises, then how we can identify the network and host and guest. Network address use the same slash nation which is known as CIDR to identify the network bit. So there is no option to specify subnet mask in IPv6. Here you only can use CIDR to identify the subnetwork. So in IPv4 there is an option to use subnet mask, but in IPv6 there is only option to use CIDR. So CIDR is very important, guys. You have to understand what is CIDR to work with IPv6 address. In this example, specified here, the network address is noted as follows. So on the top, you can see 21 CD colon 53 colon colon slash 64. This is the connected from following network address 21 CD colon 0053 colon 0000 colon 0000 slash 64 is the actual address. In short, you can write it as a 21 CD colon 53 colon slash 64. Now we have to learn about the IPv6 address types. Before we move on, I assume that you all understand what is IPv6 and what is the difference between IPv4 and IPv6. Now let's begin with the address type. There are no broadcast transmission address in IPv6 and therefore no broadcast address as in IPv4, and IPv6 supports three types of transmission as follows. So in IPv4, as you can see, every network should have a broadcast address. And every network should have a network bit or network address. But when you working with IPv6 addressing, IPv6 supports only three types of transmission. And those transmission is known as unicast, multicast, and broadcast. What is unicast transmission? Unicast transmission provides one-to-one transmission service for individual interfaces, including the server forum, sharing a single address. So that is actually known as unicast. When you use unicast address, the server load will be higher than other transmission methods. Next is multicast. So what is multicast, guys? Multicast provides one-to-many transmission service to a group or interfaces identified by the single multicast address. And in any cast, it is provide one-to-one or one of many transmission services to a group of interfaces, only the nearest of which, measured by the number of intermediate routes received by the transmission, this particular transmission. So previously in IPv4, you have also learned about the address types and the transmission methods. In IPv4, there is a transmission which is known as broadcast. But here in IPv6, there is no broadcast available. That's why the broadcast address is no longer required in IPv6. In IPv6, the transmission method will be defined in three different types. One is unicast, one-to-one communication, multicast, one-to-a-group communication, and anycast, one-to-one or one of any group. Okay, this is the difference between IPv4 and IPv6 transmission types. IPv6 scopes. IPv6 scope of an address refers to the size of its functional areas. For example, the scope of a global unicast is unlimited and the entire internet. The scope of any linked local unicast address is the immediate link, that is the local network. And the scope of local unicast consists of all the subnets within an organization. So now learn about the global unicast address. The global unicast address is equivalent of a registered IPv4 address, routable throughout worldwide and unique on the internet. So global unicast is basically the public IPv6 address. Okay. Public IPv6 address is unique and routable throughout the internet. Link local unicast address. So in IPv6 systems that assign themselves an IP address automatically to create a linked local unicast address, which is essentially an equivalent of an APIPA address in IPv4. All the linked local address have the same network identifier as a 10-bit prefix, which is denoted as 1111111010, followed by number of zeros. The rest, all the octets will be zeros. Okay, the first octet will be looks like that. The local unicast address is unique local unicast address are IPv4 equivalent of 10.0.0.0/8 or 172.16.0.0/12 and 192.168.0.0/15, which is means unique local unicast address basically used for LAN network. Okay, like IPv4 free IP class. Here into IPv6 you can use unique local unicast address in your local network. Multicast address always begin with an FP value of all R1 on bit in binary or FF in hexadecimal. So FF will be the highest value of in hexadecimal, so that's why FF. Unicast address, the function of an unicast address is to identify the router within a given address scope and send the traffic to the nearest router. And determined by the local routing protocol, organization can use unicast address to identify a particular set of routers in the enterprise, such as these that provide across the internet. To use unicast, the router must be configured to recognize the unicast address as such. Assigning the IPv6 addressing, manually allocation a user or a administrator manually supply an address and other information to each network interface. Self-allocation, which is just like its own address using a process called stateless address auto configuration. So always keep in mind, in IPv6 it is known as stateless address auto configuration, by which a network adapter can fix a IPv6 address automatically. Dynamic allocation. The computer solves and receives an address from a DHCP V6 server on the network. So using the DHCP server, we can distribute IPv6 address as well. Not only for, we can distribute the IPv6 address as well. Planning an IP transmission using a dual IP stack. Very important, guys. So the simplest and most obvious method for transmitting from IPv4 to IPv6 is to run the both. And this is what all current version of Windows are doing. Going back as far as Windows 2008 and Windows Vista, by default this operating system installs both IP versions on use of them simultaneously. In fact, even if you have never heard about IPv6 until today, your computer are likely already using it and have IPv6 link local address that you can see by running the ipconfig/all command. So if you don't know about what is dual stack IP. Dual stack means two types of IP addresses, right? So currently all the servers and operating systems using dual stack IP address, which means it is having IPv4 and IPv6 both address enabled on their adapter. By default, your system may also be enabled. So to understand, let you know, you can use ipconfig/all command to understand. You may get a IPv6 on your machine as well. The network layer implementation in Windows are both IPv4 and IPv6. You can choose to configure the address and other settings manually or use auto configuration settings. Because of Windows support both IP version, the computer can communicate with TCP/IP resources either in IPv4 or in IPv6. Beginning immediately, administrator should make sure that any network layer purchase, including the support of IPv6. Failure to do so will almost centrally cause them later. So basically, it is suggestion for Microsoft that whenever you are in a position of taking administrative decisions for enterprise network, you always keep in mind that your device, your network equipment should support IPv6 because the future is IPv6. IPv4 will obsolete in next few years. So now learn about the second technique, which is known as IPv4 over IPv6 tunneling. Right now, there are many network services that are using IPv4 only. And complexity of few required IPv6. Those IPv6 services are coming, however. The direct access remote networking feature in Windows Server 2012 and Windows 8 is a IPv6 only technology. And much of this complexity is due to the need of establish IPv6 connection over the IPv4 network. The primary method of transmitting IPv6 traffic over an IPv4 network is collected tunneling. It's called tunneling. So, tunneling is basically a transmission method so that the IPv6 traffic can travel over the IPv4 network. So this is called IPv6 over IPv4 tunneling. So this is a example of IPv4 tunneling over two different IPv6 networks. Tunneling can work in various depending on the network infrastructure, including the or host to host, router to host, and host to router. However, the most common configuration is router to router. As in this case of an IPv4 only connection between two IPv6 branch offices and an IPv6 home offices. The two routers support both IPv4 and IPv6, and the local network at each site use IPv6. However, the link connecting the two sites is IPv4 only. By creating a tunnel between the router two offices using their IPv4 interfaces, they can exchange IPv6 traffic as needed. So in this diagram, on the right hand side, we have a server with IPv6 IP address, and on the left, we have a client machine with IPv6 address. But the network device in between them supports only IPv4 over IPv6. And we have created a tunnel over that so that the client can communicate with the IPv6 server using the IPv4 network. So this is basically IPv4 tunnel over IPv6 tunnel over IPv4. Configuring tunnel manually. If you want to configure the tunnel, how you can do that? It is possible to manually create semi-permanent tunnels that carry the IPv6 traffic through an IPv4 network only. When a computer running with Windows Server 2012 or Windows 8 in functioning as one end of the tunnel, you can use the following command: netsh interface IPv6 at v6 v4 tunnel interface local address and remote address. This is the syntax by which you can do that. For an example, we are giving a live example how we can add it. You can open the command prompt using the administrator account so that it can have the right to add route on your. Then you can use netsh space interface space IPv6 at v6 v4 tunnel. Use the name of the tunnel so that you can identify. Then put the IPv4 so that the IPv4 address can route the IPv6 traffic over them. Configuring tunnels automatically. There are also a number of mechanisms that automatically create tunnel over IPv4 connections. These are the technology designed to temporary solution during the transmission of IPv4 to 6. All of them include a mechanism of expressing on an IPv4 address in the internet. This IPv4 to 6 transmission technologies that Windows supports are described in the following section. So Windows supports 624. The 624 mechanism essentially incorporates the IPv4 connections in a network into the IPv6 infrastructure by defining a method of experiencing IPv4 address in IPv6 format and encapsulating IPv6 traffic into IPv4 packets. ISATA, Inter-Site Automatic Tunnel Addressing Protocol, which is known as ISATA-P, is automatically tunneling protocol used by the Windows Workstation operating system that emulates the IPv6 link using on IPv4 network. ISATA-P also converts IPv4 address into IPv6 link layer address format, but it uses a different method than IPv6 to 4. ISATA-P does not support multicast, so it cannot locate the router in usual manner. Using the Never Discovery Protocol, instead the system compiles a potential router release, which is known as PRL, using and sends the router discovery message to them on a regular basis. using Internet Control Message Protocol version 6, ICMP version 6. And the third method is Trendo. To use 6 to 4 tunneling, both endpoints of the tunnel must have registered with IPv6 and IPv4 address. However, on many networks, the system that would function as located behind a net router and register address available in assigned to the net router itself. And unless the router supports 624, which many doesn't support as of now, it is impossible to establish the tunnel. So that means your router should support 624. Trendo is a mechanism that addresses this shortcoming by ending device behind a non-IPv6 net router to function as tunnel endpoints. To do this, Trendo encapsulates the IPv6 packet within the transmission layer user datagram protocol using UDP protocol. Rather than network layer IPv6 datagram to 4 dots. So basically, using the transmission layer, it will encapsulate the entire thing and move it to the UDP protocol, user datagram protocol, rather than the network layer in IPv4 diagram, as it does, just like 64. For a Trendo client to function as a tunnel endpoint, it must have access to a Trendo server, with which it exchanges the router solicitation or router behind a net router or not. So what we have learned, guys, this is the objective of today's class. So the objective will be the IPv4 address book consists of 32-bit addresses noted as 4-bit decimal from 0 to 255 separated by the periods. As in the example of 192.168.43.100, this is known as dotted decimal, and the individual 8-bit decimal value called octets or bytes. Because of the subnet mask associated with the IP address can vary, so can the number of bits used to identify the network and its host. The original IP standard 3 to assign network, which support different number of networks and hosts. Because of its wastefulness, classful addressing was gradually made obsolete by a series of subnetting methods, including the VLSM and equivalently CIDR. When a Windows computer it initiation to IPv4, still is addressing auto-configuration process during which it assigns each interface a link local Unicast address. The simplest and most obvious method to transmitting over IPv4 to IPv6 is to turn both. And this is what current version of Windows are doing. The primary method of transmitting IPv6 traffic over an IPv4 network is called tunneling. Tunneling is the process by which a system encapsulates an IPv6 datagram within an IPv4 packet. So guys, we have done with our classes today, and we have learned about lots about that and what is the basic functions of IPv4 and IPv6 and what are the definition of IPv6, how we can assign IPv6 addresses, and what are the precautions we should take before configuring the DHCP server for IPv6 or IPv4. So, if you have any doubt with today's class, please feel free to drop your questions so that we can answer accordingly. Thank you. Thank you all. If you have any question, let me know.